By now, you are probably quite familiar with the power and promise of large language models like ChatGPT. You've probably used it through the website chatgpt.com. What we're going to learn in this video is how to access a service like ChatGPT, but through the API. The API stands for Application Programming Interface, and it's a way to interact with an application using code rather than using a graphic user interface based website. So let's get started and see how to do this. Now the first task is going to be to get an OpenAI key. A key is a code that will allow you access the OpenAI platform from Python. If you are in the Graph Courses cohort course, you may get sent a key, so you don't need to set one up. We may send you a key that already has some credits loaded up. But if you want to update your credits or get your own key, here's how you can do this. So what you're going to do is you're going to go to this website, platform.openai.com. And in here, you're going to click to sign up for an account. And you follow the procedure to sign up. After you sign up, you should be able to click on this settings button at the top right, which will bring you to a page that looks like this. And from this page, you can create an API key using this button here, create a new secret key, and it will give you a code that you can copy. But of course, you will need to add a billing account. So you go to the billing page and add a little bit of money to your account. The models we're going to be using in this lesson, particularly GPT-4o mini, are very, very cheap. So you'll probably end up spending less than 1 cent on this lesson. So you don't need to panic about the cost unless you want to run a very big project with tens of thousands of queries. Once you've gotten your key, you can copy it to your clipboard, and let's move over to VS Code. And here I'm going to make a new file. I'm using Quarto here, but you could make a Python file or a Jupyter notebook or whatever you prefer. And I call it llmfunctions.qmd, where LLM stands for large language model. And here I'll open up a new code chunk and I'm going to import OpenAI. So from OpenAI, import the OpenAI function. So here you have a capital O and capital AI. And if, like me, you haven't yet installed OpenAI in this environment, then let's go ahead and do that. I'll open up a new terminal, and I'll just run pip install OpenAI. And now I can run this and it should work. And later in the lesson, we're also going to use pandas and numpy. So let's import those. So import pandas as PD and import numpy as NP. And let's put all of this under a section called imports. Next, let's make a new section and call it setting up the client, setting up the OpenAI client, maybe OpenAI client. And here we're going to open up a new code chunk and we'll type the following: client equals OpenAI. So here we access that OpenAI function, and then we set API key equal to our API key string that we imported. Now, actually, before we do this, let me mention that generally you shouldn't put your API keys directly in your script because there's a chance that you're going to share the script with someone and your API key will be exposed. So I don't want to teach you this bad habit, although I sometimes do it. So instead of putting it directly here, we're going to do a quick thing. We're going to open up a new file in our home folder or in whatever folder your LLM functions file is. And let's call that local settings.py, local settings.py. So this is just a Python script. And here I'm going to define a variable. Let's call it OpenAI underscore key. And it's typical that for such global variables, you just put it all in capital case like that. And here is where I'm going to paste in my key string. All right, so I've pasted that in. I've saved this local settings.py. And now I can import this in my LLM functions as though I were importing a library. So I can type from local settings, and I don't have to put the .py because it will recognize that that's a Python file. From local settings, import, and I import the name of that variable. You can see it shows up here, OpenAI key. So now this is going to be accessible to me. And so instead of putting in the string here, I can put OpenAI key there. Okay, so now we can make sure this runs and make sure that the client is successfully established. And now we can make our first LLM call. So let's call it making our first call. And the code for making a call is quite verbose. There's a lot of stuff happening in it. So you type first client, that's accessing this client here, then .chat, then .completions, and then .create. And this opens up a function here. You can see there's many arguments inside of it. The two we're going to use are the following: model equals, and we're going to set the model to be the following: GPT-4o, that's the small letter O, not the 0, mini. So we're using the GPT-4o mini model. And then my next argument is messages is equal to, this is going to be a list that will take in a dictionary. That dictionary is going to have two key value pairs. One is going to be the role. So the role is going to be set to user. Then you put a comma. And then now I'm going to give it the content. So content is going to be set to whatever message that I want to send. So here I'm going to ask the question, what is the most tourist-friendly city in France? So that's all of the code you need to make a call to the GPT-4o model. I'm going to assign this to an object called response. So response equals to client.chat.blah, blah, blah. And it may take a few seconds to run. Let's open now a new code chunk and try to parse that response. So if I just print the response, you can see in here you have ID, choices, and somewhere in there you're going to see our response. So it says France is known for several tourist-friendly destinations, blah, blah, blah. So we need some code to pull out just that response. And here's the code. We're going to say response.choices, and we pull out the element with an index of 0, and then message, and then finally content. And that will give you just the response. So France is known for several tourist-friendly destinations, blah, blah, blah. Hello, this is Kenneth from the future. I want to show you a quick way to see this whole text output because it's very hard to read on one line like this. What you can do is just right-click into the cell, right-click into anywhere in this cell output, and then you should see an option to open cell output in text editor. And if you click on that, you'll see this space over here. Now it's still all in one line, but what you can then do is you open up the command palette, click on show and run commands, and then search for the option for word wrap. So you can toggle word wrap to make sure that that is wrapped. And now it's a bit easier to view the output from the LLM. Okay, so we've made our first call, but as you can see, it has a lot of boilerplate, which is going to be very hard to remember. Now, you certainly should not memorize any of this code for two reasons. One of those is that you can easily get it from the OpenAI platform. So here I am on the OpenAI platform, and you can see that on the first page here of their developer guide, they have this example prompt that shows you how to set things up. And the second reason you shouldn't memorize any of this is that rather than type this up each time you want to use the model, we're going to encapsulate all of this into a helper function, which we will use more easily. So now let's do that. Let's make a new section and call it defining a helper function. And we're going to call our function LLM chat. So define LLM chat, or you can call it whatever you want. And that function is going to take in a message that we want to send to the LLM. Then you put a colon. And then in here, we're going to grab this code. So this code that we just put here, let's copy that, paste that. And here for the content, instead of passing in what is the most tourist-friendly city in France, we just delete that and we replace that with whatever message we send in through the function. Okay. And then what do we want to return? We want to return this thing that we've parsed out of the response. So let's say return, and we paste that in. Okay, so let's run this cell now to define our function. I see I have a small syntax error. I think I'm missing, in my case, a closing parenthesis here, and delete that closing parenthesis from there, and maybe delete this space as well. Okay, so let's run that again, and now our function is successfully defined, and we can use our function. So let's use LLM chat, and let's ask ChatGPT a question. We can say, tell me why Python is an awesome language. Awesome language. And let's run it and see the response. A few moments later, it says Python is considered an awesome programming language for a number of reasons, readability and simplicity, and so on. Now pause the video and try this out so you can get a chance to play with this function. So I want you to use the LLM chat function to ask the model for the most tourist-friendly city in Brazil. Store the response in a variable called recBrazil and then print that response. So pause the video and try that out. Next, let's open up another section and call it variables as prompt inputs. So while it is fun to use the LLM chat function in this way, the real power of using LLMs through code is the ability to iterate quickly over many variables. So let's see how we can do this. So I'm going to open up a new code chunk and I'm going to define a function called cityrec. And that function is going to take in a country as an argument, then colon. And within the function, we define a prompt. We'll define that prompt with an F string that says, what is the most tourist-friendly city in? And then we access the variable country using braces over there, then a question mark, and I'll close our quotes. And then what's this function going to return? It's going to send in this prompt now that is going to be iterating over different countries to our LLM chat. So we're going to nest in, let's say response here is equal to LLM chat, and then we send in that prompt, and we return this response. Or maybe to make it even simpler, let's just directly return LLM chat of prompt. So now I've defined that function. Let's see how we can use it. So now we can simply ask city recommendation and put in any country. For example, let me put in my home country of Nigeria and ask it for a city rec for Nigeria. And it says Lagos, and I would agree with that in this case. So now let's see how we can apply this cityrec function over an array of countries. So I'm going to create a data frame with some countries. Let's call it country df. Define that as pd.dataframe. And then we put in a dictionary in here, country, set to the following list of countries, Nigeria, maybe, and I'm just putting in random countries here. You can put in whatever countries you want, France and Canada. And let me print country df. All right, splendid. So now what we'd like to do is run the cityrec function over each country in this country df. One small issue though is our cityrec function at the moment only runs on one value. So if we try to run it on multiple values, let me show you an example. So if I try cityrec Nigeria and Chile directly in here, so it's not going to know how to handle these as individual values and iterate over them. Rather, it just takes in both values at the same time. So it says among Nigeria and Chile, Santiago, blah, blah, blah. But what we wanted to do is to take each one separately. To do that, we just need to vectorize it. So I'm going to create another function called cityrec_vec, and we'll set it to be np.vectorize of cityrec. And let me run that. And now this version cityrec_vec will work over multiple values. Let's quickly put that in a new code chunk and run cityrec_vec over those two countries. So now if I run this, it will give me two responses, one for Nigeria and one for Chile. So as you can see, this one, Lagos, is for Nigeria, and the second response, Santiago, is for Chile. And so now this we can actually use in the data frame. Okay, so let's open a new code chunk. Let's say using the vectorized function on a data frame. I'm going to make a new column called city recommendation, cityrec, and set that to be the output of cityrec_vec applied over the country column in country df. So let me copy country df there, and we want to apply it over the country column. And let's print out country df once all of that is done. Okay, and we can run the function, and after a few moments, we should now have our output data frame. Now from here, it's a little bit tricky to read the full response, but of course you could just write this output data frame to a CSV using the toCSV function, and then you'll be able to read each of the responses fully. Now here is a practice question for you. I want you to create a function called getLocalDishes, and it's going to take in a country name as input and return some of the most famous local dishes from that country. Then you vectorize the function and you apply it to country df and add a column with the local dish recommendations for that country. Okay? So there's a lot to do there. Let me quickly walk you through what you're going to do. So you're going to take this code we used to create a city recommendation, and you're just going to modify it so that instead of asking for the most tourist-friendly city, it's asking for the best local dishes. And you give it a new name, of course, so don't call it cityrec, call it getLocalDishes. And then you vectorize it. And after doing all of that, you apply it on the data frame in the way that we did here. So your final data frame country df should now have 3 columns when you're done with that. It should have country, it should have cityrec, and then it should have a local dishes column as well. So I trust you to figure that out, pause the video, and try it. Next, let's make a new section and call it automated summary of the movies dataset. And for this, we're going to need to import another package, the Vega datasets package. So import Vega datasets as VD. And we're going to access the movies dataset from that. So set movies to be vd.data.movies, and then open close parentheses. And we're only going to grab the first 5 movies using the head function, because we don't want to spend all of our API credits. So make sure you put .head here, and let's print out movies. So you can see our first 5 movies here. For each movie in the dataset, you have the US gross, so how much money it made in the US, how much money it made worldwide, DVD sales, production budget, and so on and so forth. You also have the reviews from IMDb and IMDb votes. So what we're going to try to do is we're going to take in all of the columns from here and send it over to GPT-4o Mini and try to generate some kind of automated summary of how that movie performed. This is the kind of thing that could be useful for some automated reporting. So maybe you want to have a single page report per movie. You could just pass in the key variables to the model and have it summarize the key points. So let's open up a new code chunk and let's see how we're going to do this. The first thing I'm going to show you is that I can convert this movies object into a dictionary in the following way. So movies.toDict, and then within this I'll type the argument orient equals records. And if you run this, what it's going to give you is a dictionary for each row in the dataset. So for example, here's the first row of the dataset as a dictionary. I have the title, the US gross, the worldwide gross, and everything about that movie. Then I have another dictionary for the second movie, and so on and so forth. So what I'm going to try to do is I'm going to send all of this information to the model, and I'll ask it to summarize the information for that specific movie. And I'll do that for this movie as well, the second movie, the third movie, and so on and so forth through the dataset. And so before I do that, let me store these dictionary informations in a column in the movies dataset. So I'm going to open up a new column, and I'll call it, let's say, full dict, for the full dictionary per row, and I'll set that to be equal to this output. And let me print movies again after that so you can see what that looks like. So now the very last column in this movies dataset is the dictionary that has everything about the movie, and this is what I'm going to send over to the model. So let's make a new code chunk and let's create a function which we'll call summarize movie performance, or maybe just movie performance. And it's going to take in that movie data. And for the prompt, we're going to use an f string. So prompt equals f string. And let's say considering the following data on this movie. And here I'm going to dump in that dictionary, that movie data information here. And then I'll say maybe provide a brief summary, provide a 1-paragraph summary of its performance for my report, And then we're going to send that prompt over to the LLM. So LLM chat. We're going to send that over to GPT-4o and return the response. So return the response to this LLM chat prompt. All right, so let's run this code to define that function. And let's quickly test out the function outside of a data frame context. So I'm going to take in the following data. So I'm going to say maybe name is Ken's movie and sales is 100,000 US dollars. Okay, so this is just a silly example to help you understand what's going to happen here. When I run this string here is going to be taken in as movie data, and that's going to get passed to the LLM. So the LLM is going to receive the following string. It's going to receive the question that goes, considering the following data on this movie, name Ken's movie, sales 100,000 USD, provide a 1-paragraph summary of its response. And then that gets returned here. So let me run this cell and show you what that looks like. It says Ken's movie has demonstrated a solid commercial performance, blah, 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 blah. So now this works on a single value, but in order to use it on multiple values, we want to vectorize it. So let's do that. I'm going to call it movie performance vec, set that equal to np.vectorize, and then movie performance. Okay, and now we're going to use movie performance vec specifically on the full dictionary column of the movies dataset. So it's going to iterate over each of these full dicts and return a summary. And let's store that in a variable or in a column, which we can call maybe LLM summary. So movies LLM summary is equal to this output from that function. And now if we print out movies, we can see that there's a final column with the LLM summary. Let's write this to a CSV so we can read some of the outputs. So to CSV, and I'll just call it movies outputs.csv, and I'll put it in my outputs folder. So let's grab it out of there, and I'll open it in Excel so that I can view it easily. Reveal in Finder. Okay, so here's that result. Let's look at the LLM summaries and make sure that they make sense. So for example, here it says The Land Girls, released on June 12, 1998, has underperformed at the box office, grossing only 146,000, blah, blah, blah. And so then you can quickly scroll and make sure that's correct based on the values in the columns. It looks to be correct. So typically you would see how the model performed on this task. And based on that, you could think of ways of modifying your prompt or modifying the data that you're giving the model to get better and better answers. This is what people call prompt engineering. So just doing small experiments with your prompts to get it to work for the kind of outputs that you want. Now here's a practice question for you. You're going to create a similar automated reporting function to the one we did here, but you're going to use the Seattle weather dataset from Vega datasets, which I've imported here, and take the head of it so you don't spend too many API credits just on this simple practice question. So if I run that cell, I can see that this has information on the weather for specific dates, the amount of rain or precipitation, maximum temperature, minimum temperature, wind, and then the type of weather. So you're going to send each row of this up to the model so it can give you a 1-paragraph summary of that day's weather. And then you store that in a column called weather summary. So it'll be a column in this dataset called weather summary. So that's a lot of work, but I believe you can do it. Pause the video and try it out. So congrats on getting through this video. Let's look at some of our learning objectives. So by now, you should be able to set up and make basic OpenAI calls to GPT models using Python. You can also create functions that incorporate variable inputs into your LLM prompts. You can apply such LLM functions to pandas data frames using vectorization. And you're able to apply all of this to generate automated text summaries from tabular structured data. So now you have taken a foray into programming with large language models. This is an increasingly popular and increasingly powerful tool for programmers. Hopefully you're as excited about it as I am. I encourage you to think about tasks in your day-to-day work that you may be able to automate now that you have this tool. For now, I'll be signing out and I'll see you in the next video. Bye-bye.
For more resources, visit our website where you can track your progress, access interactive quizzes and lesson notes, and connect with our teachers and other learners like you. And if you'd like a more guided experience, we also offer live online bootcamps with expert help. So join us at thegraphcourses.org to start your learning journey today.